Hey guys, welcome back to the shop. Not a work day in the shop, more of a rest day, but I'm going to take this opportunity to talk about hammers, using blacksmithing hammers, and the care and maintenance of said hammers. So this is actually take two because it seemed like as soon as I started filming, every car in town had to drive by. And so if there's car noise, we're just going to roll with it because I don't want to keep stopping, and maybe I'll try to edit some of it out. But anyway, grab a cup of coffee or whatever it is you drink. And let's talk about hammers. So this is a requested video, and I'm going to cover couple of the topics and then whatever else I think of to talk about when it comes to blacksmithing hammers. So I've got a selection of hammers here to my left. I don't know which side that is for you, but nevertheless, three of these I've personally made and a couple that are off the shelf. They've all been used extensively in the shop here. So I'll just show them real quick and then we'll get into talking about hammers specifically. This is a off-the-shelf store-bought 4-pound hand sledgehammer. I've rehandled it. I used this for a long time before I started making hammers. This is a fairly recent build. It's a straight peen blacksmithing hammer, very useful for different fullering applications and general forging. I made this one. This is a cross peen hammer, another off-the-shelf deal that I rehandled, and we'll talk about that in a minute here too. This is a 5.5 pound rounding hammer. This is the hammer that I probably use the most if I'm forging anything. This is what I use the most. And then I have a 4.5 pound rounding hammer, similar but a little bit different. And I use this a lot as well, especially over on the swage block for knocking out drifts and things like that, but also general forging. It's a little light for my liking for forging. So it's sort of just a general utility utility hammer, and I also use it for putting handles on the axes and hammers and stuff too. So, whether you buy a hammer from a blacksmith or get one off the shelf, there's some certain characteristics that you need to be aware of when it comes to using the hammer for blacksmithing. See, if we do it this way, if I just take a drink of coffee every time a car goes by, then it just kind of solves the problem, right? So, I might run out of coffee though. Little sips. Okay. So, this particular hammer right here is made out of 4140 steel. The other two here that I've made are 1045, which is what I make my hammers out of. This is the only one I've made out of 4140. So 1045 carbon steel, and I'm sure these are made out of something similar. I don't know what, but something similar, I'm sure. And typically speaking, your off-the-shelf hammers are going to be, a bit softer than at least the ones that I make, the hammers that I make. And in my opinion, the reason manufacturers do that is because they're accounting for sort of the status quo when it comes to hammer usage. They're expecting their product to be abused a bit more than, say, a custom rounding hammer is going to be. And so I think they factor that in. Plus, just the manufacturing processes are not nearly the same. They're not controlled tight, watched over, done by hand. It's a whole different deal. Whereas each one of these hammers, I'm normalizing multiple times and heat treating and everything by hand. So every single one is gets special treatment, right? So we're making sure that everything is done on them properly. You're not working with a batch of 500 or 100 hammers or whatever thrown into a quench tank. However they do it, it's not as controlled a process, is what I'm trying to say. But nevertheless, any hammer that you buy, if it's a good hammer, it's going to have an appropriate level of hardness. So when you heat treat the steel, you heat it up, you quench it, and these are quenched in water because 1045 requires a very fast quenchant to harden to the fullest possible extent that it can, and then of course is tempered after that. If you were to leave it that full hardness, it would run the risk of cracking, breaking apart, which of course not only would ruin your hammer, but would also be very dangerous. And so, in any application, most of the time, any carbon steel, you're not going to leave full hardness regardless of what you're making. And so these particular hammers are tempered, hardened and tempered for the application of using as a forging hammer. So what that means is they will forge a piece of hot steel, even something like mild steel, you know, something that's softer than the face of this hammer. You can forge that no problem. It's not going to mark up the face of your hammer. It's going to make it shiny. No big deal. And that's what it's designed to do. If you accidentally strike the edge of your anvil, or if you start using it to drive tools like this chisel, then you're going to run into a little different issue. So I'm really bad about this. I use my hammers to forge, but I also use them to drive tools and stuff. This particular hammer is a little bit harder than these two, than these others here. Maybe a little harder than it should be, kind of an experimental deal, but this one in particular, I use to drive drifts in and out, or set drifts and then drive them out when I'm at the swage block, forging axes and hammers and stuff like that. So it's rather marked up, and you know, if it gets bad enough, I'll dress the face up again. But the reason that happens is because, for example, this chisel here is obviously hardened and tempered steel, because if it was just soft, it wouldn't work as a chisel. And this is actually a cold chisel that I use as a hot chisel a lot. But the point is that this steel is similar in hardness to this hammer face, and the same deal with these drifts over here that I use. They will mark up the face of your hammer if you hit them. That's just the nature of the game. You know, for example, this chisel end, the end of this chisel could be dead soft, and you could use it like that, but it would mushroom out so bad it would diminish the usability of this tool. It's just not practical. So the way to get around this is to have a tool driving tool hammer, and then a forging hammer. If you want your forging to be, if you want your forged pieces to be nice and clean, to have that nice smooth surface, don't use your hammer to drive tools. Now obviously, I don't on this one here, I don't, you know, I'm not going to have a nice clean forged surface because it's got some divots in it. It definitely does show up in your forged piece. So, hey mama. So that's point one for hammer use, care, and maintenance, is just understanding that I think I said a minute ago, if you're going to have a hammer face that was hard enough to not be marred by hitting tools, then it would be too hard. It would be unsafe and also not durable. So that's just the nature of the business. So having, you know, a nice forging hammer or whatever, and then something that's, you know, doesn't matter if it gets beat up, because it's going to, and you can just use it to smack on tools and stuff, drifts, chisels, whatever, hot cuts, etc. So let's talk about handles next. Most store-bought hammers, if not all store-bought hammers that you get, are going to typically have some kind of steel wedge as well as a traditional wooden wedge in the handle. And this is one that I rehandled, and I put the round wedge back in as well as a little steel wedge after the wooden wedge. This is one that I rehandled. I didn't do a very good job of this a while ago, but I put in a wooden wedge and then a steel wedge, and it split that up. Most quality blacksmith made hammers, in my experience, are not going to have those steel wedges, and the reason is they're not necessary, and they make it rather more difficult to get the handle off if and when you need to. Now I will point out that the hammers that I build have a oversized eye for the very purpose of not having to replace the handle ever, if at all possible. But look at the difference there. So this is a store-bought 4 pound, this is a 4.5 pound, but the difference in the eye is noticeable. So there's a lot more material to this handle. And you'll notice that it just has a single wooden wedge, as do all of my hammers. Now, handle maintenance. When you get these hammers, they are treated in boiled linseed oil. And what that does is helps preserve the wood, but perhaps even more importantly, on the end grain of the handle, near the head and at the end, it's, you know, I apply it generously to where it soaks in, and it soaks into the cells of the wood. That alone, after a proper fitting job and a after it's been properly fitted, and that's another thing I'll say is that if you buy a store-bought hammer handle and put it in a store-bought hammer, you can shape it a little bit, but there's usually not, a lot of times there's not enough material to the handle to get to do much of that. It just depends, but these are shaped specifically to the eye that they're going into, and they're properly wedged. And then once you put that linseed oil on there, what that does is it soaks into the wood and swells it out even a little bit more and keeps the wood from drying out. It keeps that wood swelled up in there. And so as far as maintaining the handle, you'll want to apply a little bit of linseed oil specifically to the ends, and especially to the end on the head, and then also the handle end of the handle, and just wipe some on the rest of the handle as well. But again, especially right here at the end by the head, keeping just a little bit of linseed oil on there, maybe once or twice a year, depending on your environment, depending on use. That's going to keep that handle in there tight, and you're not ever going to have to worry about this loosening it up, because it's going to maintain that moisture in the wood, and you're not going to be affected, at least not nearly as much, by changes in weather or environment, stuff like that. I mean, we've all had it happen. We've got a hammer, you get it from the store, you use it for a while, and the handle dries out, and pretty soon the head on your handle is loose, on your hammer is loose. Okay, now you've probably heard of or probably done yourself. I've done it where you take and you put the hammer in water, and that wood soaks in that water, swells up, and you got a nice tight hammerhead for like a day, and then it loosens back up. This is exactly what you do not want to do, and the reason is this: when that water soaks into that wood and it tightens that handle up in the eye of the hammer, it's actually going to the extent that it's actually crushing the wood cells in the handle. And so they're deflated, essentially, they're crushed. So once that water evaporates back out, which of course it will, you are left with a handle that was even looser than it was before, and now it doesn't have that ability to swell up and tighten up even like it did before. So you're basically in a worse off position than you were before. Whereas with linseed oil, especially if you apply it right off the get-go, which of course these hammers do get that right off the get-go, then you're maintaining a consistent sort of moisture content to the wood. But the linseed oil soaks in and it swells up the wood, but it doesn't evaporate back out. So you're not dealing with that, crushing the fibers and then the water leaving it. That doesn't happen. It stays in the wood. And so, just reapplying it every so often just helps keep that, maintained. But you don't have the same problems. And so that's the best way to maintain a hammer handle. And the difference between the linseed oil and boiled linseed oil is the boiled linseed oil, the way I understand it, it's been cooked essentially, brought up to a high temperature, so it's been what's known as polymerized, I believe. And what that does is allow the oil it changes the composition of the oil to where it actually hardens to a degree, or dries, something like that, after it's been applied. And so I guess it's a little more durable, but you could use regular linseed oil, and what that is flaxseed oil that's not considered suitable for human consumption, because you can also get flaxseed oil, which is a food grade oil, and that would work fine too. But there's a number of different deals, but I use boiled linseed oil, and that seems to work great. It also imparts a nice color to the handle, in my opinion, as well. Just a nice honey color on that hickory. That's the big point about handle maintenance. And this is a jug that I've been using, and you can get it in the little cans from your hardware store for like the little quart cans or something like that. You don't have to get a whole gallon, and it's going to last you a long time. So that's kind of my spiel on hammer maintenance. Of course, it also, you know, helps. It gives a temporary sort of coat to the steel as well. And so, like when I make hammers and get them ready to ship, I dunk the whole thing in linseed oil and treat the whole thing. So it's got a fairly durable rust preventive on there until it wears off, you know. But the main thing is keeping that handle in good condition. And you really shouldn't have to, you know, worry about replacing the handle in any time in the next several decades or longer. I prepare these, you know, build these and prepare these in such a manner that you should not have to worry about that, like, ever. So that's the best way I know how to maintain your hammer and use it properly. If you guys have tips or tricks, throw them in the comment below. Help educate everybody else, the rest of us. And what else can I say? Appreciate you guys watching. We'll see you on the next video.